Namaste, and welcome back to JEE Physics with Typical Monk. This is class 26, Atoms. Rutherford fired alpha particles at a gold foil and found the atom is almost entirely empty, a speck of dense positive charge at the center with the electrons far outside. But a classical electron circling, the nucleus should spiral in and die. Bohr's daring rescue. Electrons may orbit only in certain quantized orbits, and they radiate only when they jump between them. From that single rule flow the sizes, the energies, and the exact colors of the hydrogen spectrum. Today, Rutherford, Bohr, and the spectrum, one idea at a time. Here is what you will master today. First, Rutherford's scattering and the nuclear atom. Second, Bohr's postulates. Third, the radius, energy, and velocity of the nth orbit. Fourth, the hydrogen spectrum and the Rydberg formula. And fifth, the ionization energy plus the drills, one idea at a time. 4 ideas. Run this entire chapter. Look at them together first. Rutherford, a tiny, dense, positive nucleus with the electrons far outside. Most of the atom is empty space. Bohr's fix. Electrons orbit only in certain allowed quantized orbits without radiating any energy. Quantized angular momentum, MVR, equals nh over 2 pi. Only whole number multiples are allowed. Master line. The atom is mostly empty space, and its energy comes in discrete levels. Now look at the picture, the Bohr model of the atom. The orbits. The electron circles the nucleus only in fixed orbits numbered n equals 1, 2, and 3. Stationary states. While it stays in an allowed orbit, the electron does not radiate any energy at all. Quantum jump. A jump to a lower orbit emits a photon whose energy, h nu, equals E2 minus E1, the difference between the levels. Ground state. N equals 1 is the lowest, most stable orbit. The higher n are excited states. Now, the 3 quantities of the nth orbit. Radius. It grows as n squared. Rn equals 0.529 n squared over z angstroms. Energy. It is negative and rises towards 0 as 1 over n squared. En equals minus 13.6 z squared over n squared electron volts. Velocity. The electron speed falls as 1 over n Vn equals z over n times 2.18 times 10 to the 6 meters per second. The pattern. Bigger orbits are larger, slower, and less tightly bound. Now, the spectrum that made Bohr famous. Emission. An excited electron falls to a lower level and emits light of one definite wavelength. The Rydberg formula. 1 over lambda equals r times 1 over n1 squared minus 1 over n2 squared, and this gives every spectral line. The Lyman series. Force that end on equals 1 give the Lyman series, which lies in the ultraviolet. Balmer and Paschen. Force to n equals 2 give the Balmer series in the visible, and force to n equals 3 give the Paschen series in the infrared. The pattern. Each series is a whole family of lines converging to a limit. Now look at the picture, the hydrogen energy level diagram. The levels. They crowd closer and closer together as n rises, reaching 0 at n equals infinity. The ground state. N equals 1 sits the deepest at minus 13.6 electron volts. Transitions. A downward jump emits a photon, and the bigger the drop, the higher the energy of that photon. The series. The Lyman series ends on n equals 1, the Balmer on n equals 2, and the Paschen on n equals 3. Now, the Rydberg constant and ionization. Ionization energy. It is the energy needed to free the electron from the ground state, and for hydrogen, that is 13.6 electron volts. The Rydberg constant, R, about 1.097 times 10 to the 7 per meter. It sets the scale of every line. The series limit. The shortest wavelength in a series, reached when n2 goes to infinity. Excitation. Absorbing a photon lifts the electron up to a higher level. The limits of the model. Bohr's model works beautifully for hydrogen and hydrogen-like ions, but not for many electron atoms. Now the formulas that earn marks. Radius and energy. Rn is proportional to n squared. NEN equals minus 13.6 z squared over n squared electron volts. The Rydberg formula. 1 over lambda equals R times 1 over n1 squared minus 1 over n2 squared. Angular momentum. MVR equals NH over 2 pi. Now match each formula to its meaning. En equals minus 13.6 over n squared goes to the energy of the nth orbit. Rn proportional to n squared goes to the orbit radius. The Lyman series goes to transitions to n equals 1. And MVR equals NH over 2 pi goes to the quantized angular momentum. 4 pairs, each worth memorizing. Now, how many of these statements are correct? Statement 1. The energy of an orbit is negative. Correct. Statement 2. The radius of an orbit decreases as n increases. Wrong. It grows as n squared. Statement 3. The Balmer series lies in the visible region. Correct. So the answer 2 are correct, statements 1 and 3. The trap is the shrinking radius in statement 2. Now the two mistakes that quietly cost marks. The truth, the orbit radius grows as n squared, and the energy rises towards 0 as 1 over n squared. The trap, thinking a higher orbit is more tightly bound. In fact, a higher n means less binding and an energy closer to 0. The second truth, the Balmer series, which ends on n equals 2, is the visible one. The Lyman series is ultraviolet. The second trap, using the Bohr model for many electron atoms, it only works for hydrogen and hydrogen-like ions. Now, test yourself. Answer in your head before the reveal. That is how G speed is built. Here we go. Question 1. The energy of the nth orbit, minus 13.6 z squared over n squared electron volts. Question 2. How does the radius scale with n as n squared? Question 3. The Rydberg formula. 1 over lambda equals R times 1 over n1 squared minus 1 over n2 squared. Question 4. The Balmer series falls to which level? N equals 2. And question 5. The ionization energy of hydrogen. 13.6 electron volts. Let us gather it all in one breath. Rutherford, a tiny dense nucleus, and the atom is mostly empty. Bohr quantized orbits with MVR equal to NH over 2 pi and stationary states that do not radiate. The nth orbit, Rn, is proportional to n squared, En equals minus 13.6 z squared over n squared, and Vn is proportional to 1 over n. The spectrum. The Rydberg formula, 1 over lambda equals R times 1 over n1 squared minus 1 over n2 squared, and the Lyman, Balmer, and Paschen series. The ionization energy of hydrogen, 13.6 electron volts. Next class, the nucleus, binding energy, and radioactivity. Rutherford emptied the atom, and Bohr tamed it, allowing the electron only certain orbits, each with a fixed radius and a fixed negative energy. When it falls between them, it emits a photon of an exact color, and the whole hydrogen spectrum unfolds from a single formula. Hold the n squared radius, the minus 13.6 over n squared energy, and the 3-grade series, and the atom becomes a place of perfect order. Next class, we go deeper still into the nucleus. Sarah, David, Lisa, and John all began exactly where you are sitting now. One idea at a time, you will crack G. I will see you in the next class.